Welcome. Dr. Chooks explains academic research writings, entrepreneurship and innovations, cooperative business enterprises, creativity and marketing, and topical academic subjects. Listen as Dr. Chooks explains today's concepts.
We will be talking about advanced statistics in this particular course series, and the expectation is that at the end of this series you will understand how to handle some statistical data as it concerns the field of entrepreneurship. Okay, now today we'll be talking about the nature of data and the statistical observations around data. We'll just be acquainting ourselves on these things. So we'll be talking about the meaning of data, the meaning of statistics, the purpose of statistics, types of statistics, descriptive and inferential statistics. We'll also talk about the nature of statistical methods that could be used for analysis. All right. So these are some of the things we'll be talking about today. So let us start. Now, as I welcome you to this class on statistics, perhaps it's important that we highlight some quite important things. I expect that first we'll try to talk about statistics and statistical method, and in this first series I'll introduce you to raw materials you would be working with in understanding some of these concepts and how they work and how to derive and use them probably for our daily living. Now, the relationship between data and statistics and the various types of statistics are going to be introduced as well. The approaches to statistical methods in this course is then presented with tables, with examples, illustrations, as the case may be, to make it easy for you to understand. So let's go straight to it. Let's start with the concept of data. Now, raw materials of all statistical work is data. The raw materials with which you carry out any statistical analysis, any statistical calculation, presentation eventually is data. So how do you work with data? What really is data? The raw material of all statistical work is data, whether you are looking at the enrollment figures of a school system, the number of participants from various states in an election, in a national conference, the number of successful candidates from an entrance exam, whichever you are looking at, it's data is required. These are raw materials we work with. All right. So these figures that are derived from this maybe a national census, a conference, attendance, and all that. These figures are referred to as data. All right. In a world that is increasingly demanding for evidence to support decision making, the provision of numerical data, or what is sometimes referred to as empirical data or evidence, helps to strengthen one's case. All right. In science, all observations are presumed describable either in quantitative sense or in qualitative sense. All right. When we say qualitative sense or qualitative observation, it simply means such as gender, that's qualitative classification. Gender classification are sometimes represented by figures such as zeros for female, ones for male. So when you say gender is qualitative because you are talking about male and female, just male and female. But we now use numbers to qualify, so you can give it a quantitative appearance. Now, so you can say females are zeros and males are ones. So to make the record easy for processing, we do these things. Let us quickly look at an example of how data is used in our daily lives. Let's take, for example, a restaurant. A restaurant has prepared maybe like 3 different meals or 3 different menus for lunch for a group of people attending a 2-day conference. All right. Now, in day 1, there was jollof rice, eba, fried yam, and plantain. As part of the preparation of the organizers for the group and their lunch, they put together these delicacies, and participants are required to write their names and indicate in indicate in one of the three columns their preferred lunch. Now look at this column. You see how it has been put. By the time the full attendance was taken, the following observations was made. One, you see the column before your screen now. You see 31 participants indicated preference for jollof rice, 7 participants indicated preference for eba, and 18 participants indicated preference for fried yam and plantain. Now, this observation can be translated into a table. You can see we already placed it on a table and you can see it. Now, we call it table 1, participants preference for lunch on day 1. So you can see the breakdown: jollof rice 31, eba 7, fried yam and plantain 18. Sorry. Now, let me give you a quick assignment. Identify 2 instances in which you have come across data today, given this little table we've just given here. We brought a table concerning a restaurant and how they classified a restaurant and how they made people choose from the delicacies they are preparing, and the data has been extracted. Now, a simple assignment. Now you do that on your own. Identify 2 instances in which you have come across data today. Okay, let's continue. So the use of data is pervasive. We use data every day in our lives, although we do not always describe them as data. All right, as we keep going, you understand that the things that really make up the collection of what we call data, we do not always describe them as data. Note that for brevity, we can use A, B, and C to represent the varieties that was available. Like we use A to represent jollof rice, we use B to represent eba, and we use C to represent fried yam and plantain. So that we can just for brevity, let's use that these that's alphabets to represent them. Now, if we want to know how many participants will be in the restaurant, we add these 3 variants, these 3 choices, that is A, B, and C. We add them all up and we'll get 56. Thus, we can clearly state from what we've observed that we have 56 participants, and 56 participants must be catered for. All right. Now, the supervisor can now make further decisions based on this data that we have on hand, and on the basis of the information such as how many attendants must be engaged to provide quick services, how many chairs that must be engaged to provide a sitting accommodation for these persons, the manner in which we have handled the information so far is referred to as statistics. No, we've just made a very simple analogy of how we have handled this information, and we refer the entire thing as statistics. So that helps us to come to a point where now, what is statistics? Statistics is the science of handling information, particularly quantitative information, which is data. It is the science of organizing, describing, summarizing, and interpreting data to provide concise, manageable information for decision making. That is statistics for you. That is statistics for you. Now let us consider further our example in table 1 again. Let's consider that same as example. Let's consider that same example. Suppose the following day, after table 1 represents day 1. Suppose the second day, the same menu of 3 varieties of foods. Remember, we said let's classify them as A, B, and C. A, we said, should represent jollof rice. B should represent eba, and C should represent fried yam and plantain. Now, let's say on the second day of that conference, right? And that same menu of variety of food A, B, and C has also been offered, and the choices this time around are as follows. Now look at table 2. So you see the choices as participants have decided. Number of persons: A decided. How many people decided on A? And remember, we say A is jollof rice, 21 persons. B, 17 persons, and C, 16 persons. Meaning that on day 2, tentatively, we should be expecting a total of 54 persons. Now, the supervisor that has seen this information, this data, has the opportunity to compare the two sets of data, that is data we extracted on day 1 and data we extracted on day 2. He can do so by again looking at the column total. That column total helps us to make some quick comparison. Of course, day 1 is 56 persons, day 2 is 54. So he can compare the numbers eating the same food in the 2 days and make a number of inference from this comparison. For instance, he might infer that 2 participants who failed to turn up for lunch are dissatisfied with the entire service. Remember, the difference between day 1 and day 2 is 2, 56 and 54. Now, he could just make an inference. Probably the 2 persons that refused to show up were just totally dissatisfied by their services. He may want to verify this by seeking further evidence. How does he do that? He could also infer that Eba has gained popularity and jollof rice has lost patronage. Probably didn't do so well against that's from the first day's service because of the numbers. Remember, A in the first day was 31 and now it is 21, meaning that jollof rice is losing a lot of preference. And then Eba, which is B, on the first day was 7 and on the second day is 17. That means probably the soup was good and people are demanding more Eba, meaning he can make that inference that jollof rice has lost patronage because of something and Eba is gaining preference maybe because of something again. So in addition to its descriptive function, as you can see from the table above, statistics enables you to examine patterns and compare groups. So you see the presentation of information we have here has brought up a whole lot of things. So statistics, one of the highlights of statistics is that it enables one to examine patterns and compare groups. What is the purpose of statistics? One of the purposes of statistics is that it enables one to present a large quantity of information in an organized way. It also helps you to go beyond a meaningless record of maybe school tests, conference participants, results, and so on to a meaningful interpretation out of presentation. It helps to predict. It helps one predict. It helps one to make inferences from observation. It saves one time. It helps one to save time and energy by condensing large amount of information concisely and conveniently into a table. So that's what statistics does for us. So in addition to this purpose, or what we call it now, yes, in addition to these purposes of statistics, there are hardly any discipline today, even in education, the arts, the social sciences, even medicine and all that, that does not require some level of statistics for its understanding. Research reports in most disciplines are enriched by statistics. Lastly, one requirement for higher degree in most disciplines is that you carry out and report your own independent research, which we often call projects, theses, dissertations, as the case may be. Some school managers are constantly facing situations in which they have to make inferences from observations. For instance, the properties or proprietors of a private school who has organized a kind of gathering of information on weekly attendance and found a couple of notable things when such information is gathered. So you will, from this, look at this table now. Look at this table concerning attendance. You see weekdays. We have weekdays here, Monday to Friday, and you see the numbers of attendance in that particular school. We can call it school A, as you can see here. So if that proprietress makes similar observation over several weeks, the proprietress can deduce from that from the attendance that hardly full attendance in the school occurs, or you can deduce that there's hardly full attendance in a school day. She may also deduce that attendance is least towards the weekend. That is, as the weekend is approaching, people start attending less. So you see, this is what statistics can do for you. You do not always know what type of research you will carry out, whether it is a documentary analysis, a historical analysis or an experimental study. You do not know that. So however, what do you now do? So you find knowledge of statistics most valuable in your own reading, in your own specific environment where you work, and then you use it to your own advantage. Now, what is the types of statistics that we'll handle today? One, descriptive statistics. Like we said earlier, the three types of statistics. One, descriptive statistics, which refers to the number of presentation of large amount of data. Number two, correlation statistics, which allows you to examine patterns, compare groups, and predict future events from extrapolation from this data. And then number three, inferential statistics, which as the name applies, allows you to draw out facts that are not immediately available or visible from the data presented. So we have descriptive and inferential statistics. We also have correlational statistics, as you can see it here. Okay, that's about it for today. Now, in our next session, we'll be talking about basic concepts in statistics.